Of course, we want to get good results with our ultrasound scan. To be able to thoroughly assess all the organs, it is important to have an optimal picture. We need the right frequency, the right gain, the right depth of the picture, and the right focus.
First, we choose the right frequency. When we are using low frequency, we have got a good penetration of our ultrasound beam, so we can display structures in the far field. But we lose detailed information in the near field. So the higher the frequency, the more details can be seen on the screen. So we start with a quite low frequency of 1.9 megahertz, and we can nicely see the penetration is very good. We can see structures that are quite far away from the transducer, but the details are not so fine. So I'm going to increase the frequency step by step. Now we've got 4.0 megahertz, and you can see the picture on the screen is getting darker in the far field, so we lose information in the far field, but the detailed information in this region is getting even better. And I tried once again to increase the frequency, now using 6.0 megahertz, and the information is getting even better over here. But I think this frequency is too high because I'm not able to display far field regions over here, so I cannot clearly display this far region of the liver.
So it's 4 megahertz in this case.
I think so. We have to take 4 megahertz, which is
Try this again.
a quite fair adjustment for scanning the liver.
The next adjustment we want to optimize is to have the right gain, the brightness of the picture.
So over here, I think we cannot see anything because the gain is too low. I'm going to increase it, and the picture improves.
Magically.
But there's a point we have to stop. There are vessels seen in this picture, and they have to be black and echo-free. And so I have to reduce the gain. I think this would be fine.
Yes.
And echo-free structures are really black on the screen now.
It is also important that the area of our interest fills the screen, so we have to adjust the depth of our picture.
So over here, we are going to scan the liver, but the liver is only in the upper part of our screen. So we can reduce the depth, and we will increase the size of the picture of the liver. So, but we have to be careful not to magnify the picture too much, because now I cannot see all the borders, so I have to reduce the size of the picture, and now I can easily detect the diaphragm over here and all the borders of this organ. So I think that's the best adjustment.
In optimizing frequency, gain and depth, we already did a good job, but we can get even more information when we change the focus of the picture.
Now the focus is set to the mid of the picture, so the most detailed information is given over there. When I change the focus zone to the near field, we get a very distinct and detailed information of this area, but we have to get information of all of our picture. So I change the focus zone to the very bottom of the picture, to the far field.
Or at least 3/4 of the picture.
Yes, so that's the best adjustment for all of the settings. Let's perform a scan of the liver. The liver is a quite great organ, so we need an
systematic approach.
for scanning the liver. Can you show us how you do it?
Yes. I start placing my transducer into the epigastric area in a longitudinal position, into the longitudinal epigastric view. And I ask my patient to inhale and hold his breath. And so, Christian?
Fine. We see the left liver lobe. Very beautiful over here. On this side there's something moving. It's the patient's heart. So the cranial portion of this screen we see the diaphragm over here, left liver lobe, and the caudal border in contact with the gas-filled stomach over here.
We let our patient breathe again. Okay, then we take a sweep to see the left side of the left liver lobe and ask our patient to inhale again. And as you can see, I sweep my transducer, I tilt it to the left side of the patient, slowly, and keep the left liver lobe in the center of my picture and tilt the transducer far to the left until I can see the last tip of the left liver lobe, and then I move back again, tilt the transducer again until I'm again at the midline.
Great. So, from the left side to the right side of the liver. The patient is placed on his left side, raised the arm above the head, and we go on with the scan of the right liver lobe.
I place my transducer again in the epigastric area in a longitudinal position. And now I perform a sweep to the right side of the patient. Since the liver is a quite large organ, we cannot scan it at once. So on a first sweep, we focus on the cranial parts, and on our way back, we sweep the caudal parts of the liver. Okay, please inhale. I start to move my transducer to the right side of the patient, and I focus on the diaphragm so that I know that I have the cranial parts of the liver in my view.
You have a perfect view on the diaphragm here. This bright hyperechoic line over here. Brilliant.
I don't change the axis of my transducer. I let my patient exhale now and inhale again, please. And on my way back, I focus on the caudal rim of the liver. I have to apply some pressure to get good contact.
Keep the caudal liver border in mind over here.
I'm sweeping back until I come again back to the midline of the patient.
Can you show us the very left liver segments again in the second plane?
Yes, certainly. I start from this longitudinal position again, and now I turn my transducer slowly anti-clockwise into a nearly transverse position, but I have to adjust to the left costal arch. And I ask my patient to inhale and hold his breath. And then here we got the left liver lobe in the other plane, and I slowly tilt my transducer and perform a sweep left liver lobe until to the very last tip, and slowly sweep back again so you can easily observe the tissue over here.
You have already seen the heart. Do you want to perform an echo?
Nearly, yes, but actually we're really very close to the heart with these liver segments over here.
In the next scan, in the cross scan, we will see some interesting landmarks. Can you show us?
I'd love to. Actually, this is my favorite part of the liver scan. I place my transducer in the epigastric area, adjust it to the right costal arch. Then I ask my patient to inhale. The nose of the transducer is pointing towards me. Then I tilt the transducer steeply upward. And then I perform a sweep slowly downward, slowly, until I get to see this structure.
Great.
You can exhale, thank you.
You got a perfect view on the liver veins.
Yes. It's beautiful, isn't it?
Is it? It is. There are 3 liver veins, the left one, the middle one, and the right one, and the confluence to the vena cava inferior over here.
And somehow it looks a little bit like a bunny to me.
Yes, you are correct. Some say it looks like a star, the star of the liver veins, but it's a bunny.
And actually, the more it looks like a bunny, the higher the likelihood for liver congestion. But this we will discuss in our chapter of liver pathologies.